Hello and welcome to the second part of the Dynamics 365 Lego Rental IoT app. Before we jump into details what I want to show you in the second part, let's have a quick review of what we did last time. So last time we started here on top with a couple of resources that I set up. They basically represent my Lego vehicles, and then we made use of an existing app, Book My Room. This is a template app to rent out these resources. Of course, we extended this existing app because it does not contain all of the information, but at the end of the day, we were able to allow customers making bookings. Then, once a customer made a booking, we send an Outlook blocker in our calendar so that we cannot double book or double rent a vehicle, and then the customer get a confirmation email. Then we also created a rental contract in Dataverse because we needed that one for invoicing. And then after the customer returns the resource or the vehicle, we updated the contract, we created an invoice, and then we created a use-based depreciation. So that's what we did last time. And now, the last time, when we returned the vehicle, we selected here on top the customer account, we selected here the rental contract, and then we entered here the actual return date and time, and we also entered the mileage at the end of the trip here manually. Yeah? And that's what I want to change this time. Yeah? Not this date. I just want to focus on the mileage because that's the one that we use for invoicing. Yeah? And also depreciation later. Okay, then how does this work? Yeah, so basically what we need is a kind of odometer that measures the distance. Then we transfer the data to an IoT hub or cloud, and from there we transfer the data to our app. Yeah? And how this works is described now in the following. So the step A basically means we need to create such an odometer or speedometer. Yeah? And if you need some ideas where to find ideas how to do that, have a look at a couple of YouTube videos. I liked especially this one where somebody put a microcontroller at his bike to measure speed and distance. That one is quite nice and important. And then later on, I have an other very detailed recommendation for a YouTube video that deals with time interrupts. So time interrupts, why we need them? Well, let's have a look at some technical things first. Yeah. So the whole device works with a reed switch. A reed switch, that's what you find on your bicycle, yeah, where you have basically a magnet that is rotating with your wheel, and then here's something fixed to your bike, which basically opens and closes a switch here. Yeah. So as the magnet comes closer, the switch closes and sends a signal, and if the magnet circulates and goes away, it opens again. Then the other thing that you need is an idea about timer interrupts, and here I would highly recommend this blog post or this description how this works, because that's crucial for measuring the speed and distance. And then you need some basic knowledge about circumference, p, and the radius, and how to measure distance and speed with that. Okay, and here is the example of what I mentioned. Yeah. So here's our wheel, and that's the magnet. The magnet passes the reed switch and closes it. Once this closes, then we are here at the clock, and then we reset the timer to measure the time until the magnet closes the reed switch again. So that's the basic concept. And to implement that, you need a couple of things to code. First of all, you need kind of the device, the reed itself, and a storage. because you do not want to start at 0 kilometers each and every time you start running this. Then here in yellow, that's my time measurement. And then here, this one here measures the speed and distance. And here I basically did a kind of trick because I'm dealing with Lego cars and I do not want to sit hours and hours to run this thing for kilometers. So I changed it, the thing that I divided my distance with, yeah, and I changed something in the circumference and the wheel, yeah. So later on I basically have a wheel with a circumference of more than 5 meters, so just that I do not have to spin that wheel so often, and to show you the demo with some reasonable data. And then once you stop driving, then I have here an internal storage EEPROM is called, that is basically storing the kilometers traveled after 10 seconds here basically. Yeah. And that's how it looks like. Yeah. So here we have the magnet. That's the magnet. The yellow one is my wheel, my Lego wheel. And then here I have a kind of a weight just to make this spin nicely. Yeah, because if you have only a heavy magnet on one side, then this does not really circulate nicely. Yeah. Then here, that's my reed switch. That's the magnet switch inside. And then this one connects to my microcontroller. Yeah. Here, this one represents the vehicle wheel and this the vehicle body. Yeah. And because this one is quite tiny and I do not want to destroy the Lego parts of my son, I basically created this own construction. And also because this is really tiny stuff, so if you have big fingers or bad eyes, then you need to construct something like this. But feel free to do something similar and put it on a Lego device, maybe a bigger one than the ones that I have, but will be fun to have this really tied to this Lego tie. Okay, after this short introduction, let's have a look at how this speedometer or odometer works, and then let's switch here gears and then do a short demo of this device. Okay, so now I'm here on my computer, and on the left hand side you can see the Arduino Ide. So that's where I basically enter the code, and as I mentioned, I used a couple of examples that I modified and adjusted for my purpose. And once you are finished with your code, you can upload it to your IoT device, or in my case, it's currently a microcontroller. And then you have here what we call a serial monitor that shows you the current distance traveled, so 48,101 kilometers. And now if I go to my device and if I spin this, then you can see, hey, the distance is going up, the kilometers per hour are going up. And after a while, when the kilometers per hour is going back to 0, so when the travel basically ends, this distance will be stored, so 48,157. And then if you have the next customer that comes in and who starts the engine again, you see that this is the old distance, and then you add on top of that, and then there's another travel recorded. And what we need later on in our Power App is basically this last distance measured after each customer or when each customer returns their vehicle. And the way how this works, this is something we will investigate first in my PowerPoint, where I explain you the principle, and then we do another couple of demos where we see how this can be then transferred to our Power App and to Dataverse. So let's go back to my PowerPoint. Okay, so after this first demo, let's have a look at the next step that we need to do. And the idea is, of course, we want to transfer the data to a cloud storage, because we need that for our app and the Dataverse table that we have to have the data there. But now, when we try to do that, we have a problem with this Arduino board that I just showed you. And the problem is that these boards are on-prem boards, basically. So they do not have a native cloud integration. Yeah. So what can we do? Well, we can use a different board. I used here the Arduino Nano IoT board, which is one of the cheapest ones that you can get for that. But this one has another problem. So it helps you to connect the data to the cloud, but it uses here a different chip. And because of the different chip, some of the features that I used before in my code don't work. So you cannot just copy and paste the timer and this flash storage, because this works differently. Yeah? And therefore I had to adjust the code, especially for the storage that stores the kilometers traveled. And here we use a flash storage instead of this EEPROM. And the timer interrupt is different. And what I used is here an example from GitHub that calculates the rotation per minute, basically. And I adjusted that for my example to measure the distance and the kilometers. Yeah? And yeah, to give you some idea of what flash storage means, maybe some of you remember this Harry Potter movie scene where they also use flash memories, how they call it at that time, to reveal a secret, and that's kind of similar what we are doing. The principle or the way how this works is as follows. So we have here this measurement device, this microcontroller that transfers the data to the Arduino cloud. At the moment, I'm not using Azure Cloud because I still need to develop and learn more about that. But maybe next time we will do that. And then from this IoT cloud, we use this time an HTTP call via an existing API. So the Arduino IoT cloud has an API framework that we can directly connect to with Power Automate. If you remember my last blog post on the money counter, we used a webhook and then a Google Sheet to store the data. That's something I do not want to use. I directly want to connect here the data, basically the last distance recorded via an HTTP call in Power Automate. And once we have the data there, then we transfer and update the data to Dataverse and our Power App. And that will be part of the next demo, which might take a bit longer. So take something maybe to drink or eat and then come back. Okay, I'm now here in my Power App. It's the same that we used last time, but I added a small modification. Yeah. So let us try to go through the whole process from A to Z. Yeah? So first of all, I want to render a vehicle. Yeah? And I want to render a special one. Let's say maybe from 8:30 to 9. No, it's not available. So let's make 9 to 9:30 then. Let's see if it's available. I want to have this racing car. Yeah. Why? Because the kilometers on this racing car are currently 1036. Yeah. And this value comes from my sensor readings. Yeah. So if I change into the Arduino cloud and here into my dashboard, you see that this is the distance that I'm currently traveled with this vehicle. I just skipped the decimal places and just used the kilometers here. Yeah. And now we want to basically rent this car, drive it, and then return it, and then see what kind of documents we get. Yeah. So let's rent this car first. Yeah, for this customer. That's my most famous customer, Lothar Matthäus, an old soccer player. And I'm doing now here the same steps that we did in the last post. Yeah. So if you do not remember everything, just have a look at the previous post. And I'm booking this vehicle now. Yeah. So what this does is it sends out a confirmation email to my customer's email address. So if we are here, we should see, yeah, okay, here's the Lego racing car. For this customer, this is the vehicle, and here I have the starting kilometers. Yeah, that's what we did last time. And also in the calendar, we will get a blocker so that nobody else can rent the car at the same time. Yeah? Okay, so then the next step is basically for this customer to drive the vehicle and then return it. And for driving the vehicle, let us have a look at my board here. And at the same time, I have here my camera. Let's try to switch it on, where you can see basically my new board. So this one, this is the Arduino Nano IoT 33. And this setup is basically the same that we used before. I just used a different pin here, or at the bottom here, a Lego plate that is green, so that I know what is the difference. Okay, and now the situation is, okay, I'm sitting in the car and I start traveling. So this is what we just simulate by spinning the wheel here. And if we stop, then there will be a timer running. And after a couple of seconds, I think I put 5 seconds, then there will be an update on the dashboard. So you see that the number increased to 1080. So if I continue driving, so let's see, and then stop again, then the number should increase again. And 1111. So, and now the question is, how do we get this information after the trip into our Power App and then into Dynamics? And that's what I want to show you next. And for that purpose, we move into here, Power Automate. So what I have here is basically a flow. I tested it a couple of times before. The flow is triggered from the Power App. That's a button that I added. I will show you that later. And then we grab the customer data and the contract data. Why? Because we need to assign the kilometers from the sensor to the rental contract to update the ending mileage. And then we have here a HTTP connector. What is that? Well, this one connects to the Arduino cloud. It basically grabs a token based on some information that I give. And the way how this works is basically described here in the Arduino Cloud API. So you create an authority token by filling out this information. So you have a client secret and a client ID that you put into this. Wrong one. That you put into this HTTP connector. Then you get a token back, and then with this token, you can then come and grab the data from the dashboard. So this is from my last run, and then you see here what kind of information you get. But what we are interested in is basically just the distance. Oh, where is it? Yeah, so the last value. So previously it was 1036. And you see that we also get a timestamp. So you know when the trip was basically finished and when these kilometers can be recorded. Of course, I could have put a button into my sensor or close to my sensor and send a signal when I lock the car or something. But this is something maybe for next time. But here now with this information, we basically split the values, this JSON string, and then you see the last kilometers that I get, the last date time that I get, and what we use with this information is we update the rental data. So I'm grabbing here the record. I have a filter here that filters for this specific record, and then I update the row, and this update is done with the last kilometers that I have. And then, of course, I give an information back to Power App so that I can see the kilometers when I return the car, because that's ultimately important also for depreciation in my example. But if you want, you can also use that for invoicing. So let us go back to the app. So now we simulate that the customer returns the vehicle. So we click on return. And here on top, we have to select the racing car. Yeah? So the starting mileage was 1036. Yeah? The ending mileage is not 1036. Yeah? Because that's something we want to have updated automatically by reading the sensor. And reading the sensor, I included here this flow. This basically triggers the flow and gets a value back that should update this field. So let's see if this works. If there's no big mistake, yeah, then you see this is the mileage. That is basically here the result from our sensor. And with this information, I can now say I process the return. And what happens is, as we saw in the last blog post, a free text invoice is created inside of Dynamics. So let's see if this was done. Takes a while to update a bit. And then we should see an unposted free text invoice, hopefully, if there is no mistake. Yeah, so we can see here on top, there's an unposted free text invoice. If we click into that, you can see this is for this contract with a starting value of 1036 kilometers. Yeah. And what I did is I just invoice the customer based on the time. I did not include the kilometers here. The kilometers are just used in my example for a use-based depreciation. But let us first complete the invoicing process here. So I sent basically a customer invoice out here with these print management parameters that trigger an electronic invoice and send it out to the customer's email. So if we refresh that, then the customer should see his invoice based on the time, on the rental time. But as I said, if you want, you can also make it dependent on the kilometers. And then the other thing that we did the last time is we used the kilometers and the distance traveled within a month to calculate the consumption-based depreciation. So let me go back here into Dynamics. So if I refresh that, you see I cleared all of the data that we tested last time. And now the expectation is, okay, I have some transactions recorded in the previous months. Let me show you that, what is in the depreciation table. So here we have this rental depreciation table. And if I go in here, I can see these are my values for February. These are my values for March. So here's the beginning value. So the beginning travel distance at the beginning of the month. And what we want to fill is this one here. And for that I have the other flow. So that's the one that I used also last time. And if you remember, it basically runs here on a monthly schedule. But because I do not want to wait here until month's end, I just start it manually. And then we should see an update then in this rental depreciation table and also in the consumption factors. So once this is through, we should be able to come here and then see, hey, in this month or in the last period, we were traveling 1001 kilometers with the racing car. So let's quickly verify that. So if I go here inside and refresh that, then we see now here the values for April. So the ending balance here is the beginning balance of the next month. And the use-based depreciation is basically here for this month, for March, the difference between ending and beginning. And 1111 minus 110 gives exactly this 1001. Here we have 789, which should be the difference between 11 and 800, and so on. So that's how this use-based depreciation is calculated. So the next time you run a depreciation run, it will consider the kilometers that were traveled in your financial accounting system. But actually the most important thing that I wanted to show you was basically this integration of an IoT sensor and the readings that we can make here with our Power App and Power Platform by means of these HTTP calls. So if we go up here again, so here this is the key that we have a first call here where we post a transaction, get a key, and then use this authentication key to get the sensor data, and then update Dynamics, update Power App, update different tables in Database. Okay, that's it, what I wanted to show you for today. I hope you found it interesting. So let's go back to my PowerPoint for some closing remarks, and then let's finish this post. So after this demonstration of the IoT sensor and how we can use it and integrate it with Dynamics, let's quickly summarize what we did. So in the first blog post I showed you how we can set up resources and show them in a standard Power App where a customer can then basically rent these vehicles, and then we transfer the data, the rental data, to Dataverse, and then we do something like creating invoices or creating use-based depreciations. And in this post we added on that and said, okay, we read the kilometers from the vehicle, put it in the cloud, read it with an HTTP connector in Power Automate, and then we update the rental data and then make use of this use-based depreciation in finance and operations. So that's what we covered, and I hope you found it quite interesting. What you can do that goes beyond Dynamics 365 and the Power Platform. So thanks a lot for watching and listening, and then let's end this post.
What are you doing?
Well, I'm cleaning your vehicles here. You said I have to clean them.
That's that.
Yeah, I'm cleaning. Yeah. Next time I will take the drone again. Then I do not have to clean all that stuff.
And what is with my bonus?
You still want to have a kind of bonus? Let me see. Here, I have some chocolate eggs for you. Is that sufficient?
Yes.
Okay, good. Then thanks for watching. Until next time. Bye.